Okay, that is correct. I just had to double check, make sure. For some reason, it looked funny. Yeah, but that is correct. Okay, so the way we get our critical value of z is we want 85% confidence. So then we'll go to our critical value of z table. Okay, so standard normal table, critical value of z. And then what was our confidence? It was 0.8, 85% or 0.85. Okay. So 85%, our critical value of z is going to be 1.44. Okay. So we'll have 1.44 times the square root of 0.349 times 1 minus 0.349 divided by 510. And again, you don't want to round too much, so leave 5 or 6 places here. Okay, so the way I like doing these is I like doing the square root part first. So I'll do the square root of 0.349 times parenthesis 1 minus 0.349, close parenthesis, divided by 510. And it gives me 0.0211, a bunch of junk. And then we do times 1.44 to get our margin of error here, which is 0.030393. And let's make some room here. So then we take p hat, and we're going to add and subtract the margin of error. So 0.349, you treat p hat just like x bar, plus 0.030393, and then 0.349 minus 0.030393. Let's see what we get. So 0.349 plus 0.030393 is this 0.3793, so that will stay at 0.379. And then 0.349 minus 0.030393 gives me 0.3186, so that one will round up to 0.319. Those will be our upper and lower endpoints on our confidence interval here. Okay, last one. 16 says a fast food manufacturer wishes to know how many fast food meals males over age 28 eat each week. Suppose a sample size of 865 is drawn, that's n. With x bar, that's pretty clear, of 5.8. Assume sigma equals 1.1, so this is sigma known, we'll use z. Construct the 95% confidence interval. Okay, so first of all, we got our starting point, x bar is 5.8. The other thing we need to figure out is our margin of error. This is a sigma known situation, so we will have z sub alpha over 2 times sigma over the square root of n. The way we figure out our z's, we look at our confidence. So we want 95% confidence, or 0.95. So for 0.95, our critical z value is 1.96. Okay. So 1.96 times our standard deviation, which is 1.1, divided by the square root of our sample size, which was 865. And then we're going to leave several decimal places here. So 1.96 times 1.1 divided by the square root of 865. So we get 0.035905 if you keep 6 places. And then we'll do 5.8, our sample mean, plus that number, the 0.035905. It says round our final answer to 1 decimal place, so let's see what we get. 5.8 plus 0.035905, and we round, we get 5.8. It didn't change much. And then 5.8 minus our margin of error. See what we get there. 5.8 minus 0.035905. Get 5.76, so that one actually rounds up to 5.8, so that one it's kind of weird. Okay, but we get the same number on both ends. We should really probably leave another decimal place, but it tells us to round to 1, so we're good there. Okay? If you have questions, let me know.